Okay, so this is the third video in our series about connecting sensors and outputs to a Raspberry Pi. And if you haven't watched at least video 1, where I talk about connecting the Raspberry Pi using this interface board to a breadboard and a ribbon cable, you should go back and check that out to see why it is that we're doing this right here. And the sensor that we're going to be taking a look at in this third video here is a light sensor. It's got a little sensor here that changes resistance when light shines on it, and then it can send a signal out and tell us what's going on. Now, if you notice on this sensor, and it might be kind of hard to see in the videos, but there's actually 4 pins. We have our standard VCC and GND. We also have a digital output, which can turn on and off with a preset amount of light. And we can turn this screw right here to determine exactly what amount of light will make the sensor turn on and off. But if you want more information than that, there's also an analog output on this sensor, and that will tell us a number indicating how much light this sensor is getting. So we can make our own decisions about whether that's a lot of light or a little light. Now, unfortunately, Raspberry Pi does not speak analog. It speaks, when it reads signals on these pins right here, it is interested in knowing whether that pin is on or off, not whether it is sort of on or mostly off or anything like that. So to be able to use this sensor with a Raspberry Pi or any other analog sensor, we are going to need to translate that analog signal into a digital one that the Raspberry Pi understands. And to do that, we are going to use this integrated circuit, this IC or this chip right here. This is an MCP3008, and it is an analog-to-digital converter. So it's going to take the analog from the sensor right here, convert it into a series of digital signals so that the Raspberry Pi can read them. Now, you might be wondering, how in the world does a signal with lots of different values in it, up or down, get translated into a simple on or off? So the answer to that is that it's not just one on or off. This ADC chip here will send a series of pulses, a series of on, off, on, off, until the Raspberry Pi knows enough about that series to turn it back into a value over here. If you have past experience with binary numbers and how those work, you know how a series of ones and zeros, or ons and offs, can be used to represent a much larger or more accurate number. And that's what's going on with this right here. Now, that chip right there, to be able to send those signals, uses a protocol called the serial peripheral interface. And that is not very relevant, but if you're interested, I'll just briefly show you that this is defined in a number of places. This is from Wikipedia right here, and there's a specific set of rules about how the wiring goes in between the Raspberry Pi and the ADC chip. And what that means is that we have a number of wires that we need to connect to our Raspberry Pi from this ADC chip. In fact, we have 1, 2, 3, 4, 5, 6, 7, 8 wires, and that's just to get the chip talking. That doesn't even include this analog sensor here. Now, I've used these short jumper wires that are designed to go along the flat face of a breadboard. And there's nothing wrong with using a series of long wires like this. But if I do that, this is just going to turn into a jumbled mess right here. And so for clarity, I'm using these shorter ones instead, so you can see what's going on. Now, from my breadboard here, I doubt very much that you'll be able to see exactly what gets connected where. But I want to point out one important thing about this chip, and then I want to send you to the resource that will help you out in here. There's 2 different ways you can put in this chip. You can put it in like this, or you can flip it 180 degrees. And when you insert a chip, it's important to keep track of it, and there's a tiny little dot next to one pin on that chip. And that dot signifies pin 1 on the chip. And I have put this in so that that dot is in the upper right-hand corner. Now, when you wire this up, if you want to make sure that you're on the right page, with that dot in the upper right-hand corner, all of the SPI connections, all the interface to the Raspberry Pi, are going to be on the bottom side of the chip. So you can see all my wiring coming down here with that dot in the upper corner. And then my connection from the analog sensors to this chip is going to be on the top. So to actually wire up that ADC, I'm going to send you to the excellent Adafruit website using the MCP3008. It explains why we need an ADC, and more importantly, it shows how to wire it together. Before I show you those instructions, let me just put in a plug for Adafruit. They are a store. They sell all things Arduino and Raspberry Pi, among other things, and they have excellent resources as well for how to wire all of these things up. I buy parts from them very frequently, and I refer to their tutorials all the time for how to wire things. And so they're an excellent resource that any electronics person should be aware of. If we scroll a little bit further down in that same web page that I'll link in the comments here, we see that there is a very clear tutorial here from Adafruit on exactly which pins right here need to go to which parts of the Raspberry Pi connection board right there. And following this will get you to the point where your Raspberry Pi is going to be wired up to that ADC chip. Again, it looks a little bit complicated, but there's about 8 wires that we need to connect, and once we get those connected, then we are back in business with our ADC. Okay, now the next step then is to add our analog sensor somewhere over here, and we will connect VCC, GND, and then this time we're going to connect A0, not D0. So boom, there we go. We can see that we have this wired up, and it's showing us some lights indicating that we have power. And you'll notice that these 3 jumper wires are not going maybe where you would expect. First of all, VCC and GND, I didn't take those all the way back to 3.3 volts and ground over here. If you look carefully on your breadboard, you'll notice that these stripes along the edge, colored in red and blue down here, also have labels indicating that they are 3.3 volts or they are 5 volts, and they are, so this one needs to, this one needs to go over here to 3.3 volts. And they are also places that you can plug in. I took advantage of that with the ADC chip here as well, to bring those just down here instead of going all the way back to GND and 3.3. And then our last wire, our analog output from the sensor, needs to go into the ADC. This ADC chip has 8 channels, meaning that it can read in 8 analog sensors at the same time. In this case, we're using channel 0, which happens to be the pin with the dot next to it right there. And that is plugged in right there. Now what we need to do is we need to bring in the Python code, and we need to get our Raspberry Pi measuring that sensor value. Unfortunately, the code for an analog communication sensor with an ADC is quite a bit more complicated. We're not going to take the time to go through everything that's in this code. It will be linked for you. But what you should notice is that there's some setup things with pin numbers at the top. We're going to set the channel that we're going to read. We're going to do a lot of setup of in and out. And then there's a fairly complicated section right in here that's designed to send the right pattern of 1s and 0s back and forth between the IC, the ADC, and the Raspberry Pi. And that is that SPI protocol that I was talking about. There's some reading and writing that goes on in there. But the main part of the program comes down here. We are going to initialize our ADC. We're going to set it up, and then we have an infinite loop that is just going to read the value of the channel and print it out and sleep for 1 second. And it's going to do that over and over and over and over again. And by the way, this line down here is actually optional. We never get there. So that's the gist of the program right there. We're going to read the input channel. We're going to print what that value is, and we're going to sleep. So let's actually run this code right here and see what happens when we connect our analog input into our Raspberry Pi. So here we're in the terminal again. I am going to run the analog in program right there. You can see that it's initializing our ADC, and then it's starting to type out some values right there. Exactly what we might expect. Okay, and then what I'm going to do is I am going to, let's see, is that going to be big enough? That might be a little small. Let's flip that around like this. And I know those values are starting to scroll off the bottom of the screen right there. Let's see, why don't we do something like this? Now, if I take that light sensor and I cover it up with my finger, you can see that those values, now this is kind of funny, the values are backwards. Less light seems to indicate a higher number on this sensor. And if I take my finger away, those values go down. And then if I bring in a really strong light, like this, those values get even lower down there, down to the single digits. And you might guess correctly that the lowest you can go with the highest amount of light would be a value of 0. And I might leave it up to you to figure out what the highest possible value that you can get out of this string of numbers is right here when you actually cover it completely in the dark. And I'll give you a hint, this is a 10-bit ADC. That means it uses 10 binary bits to convey the amount of information from the ADC back to the Raspberry Pi. Okay, so that's it for our video on connecting analog sensors. I just wanted to point out that once we've gone to the work of connecting the ADC here, remember it has 8 channels on it. And so if you go to the work of doing this, you can connect other sensors here as well. And in fact, there's nothing wrong with even connecting the digital sensor over here. You'll get one of two values. It'll either be 0 or it'll be a very high value, and you can use those values to determine whether the sensor is on or off. And so think of this as an 8-input interface into your Raspberry Pi.